Again, welcome to DSRT 734 class, Inferential Statistics in Decision Making. These lectures cover probability, the addition rule. So our main objective is to determine if two events are mutually exclusive. Also use the addition rule to find the probability of two events. So mutually exclusive, two events A and B cannot occur at the same time. Then we say the event A and B are mutually exclusive. As shown on the diagram, A and B are mutually exclusive because we can see the Venn diagram here on the left. A and B cannot occur at the same time. The intersection of A and B is 0. Now, when we look at the second diagram on the right side, A and B are not mutually exclusive because we can see intersection of event A and B, which means event A and B occur at the same time. So if two events can occur at the same time, then they are not mutually exclusive. If two events cannot occur at the same time, then they are mutually exclusive. Now let's look for some examples here. Here they say we should decide if the events are mutually exclusive. The first event, we roll a 3 on a die. The second event, we roll 4 on a die. Now, if I roll a die, only one side will show up. Two sides cannot show up at the same time. So these events are mutually exclusive. Now let's see the solution. Mutually exclusive, the first event has one outcome, which is 3, and the second event also has one outcome, which is 4. These outcomes cannot occur at the same time. So in a very simple conclusion, when we roll a die, two sides cannot occur at the same time. So this event is mutually exclusive. Now, the second example, decide if the events are mutually exclusive. Event A, we randomly select a male student. Event B, randomly select a nursing student. This event A and B are not mutually exclusive because we can have a male student also is a nursing major. So select a male student and randomly select a nursing student is not mutually exclusive. So our solution is not mutually exclusive because the student can be a male and also it can be a nursing major. Now, next we go to the addition rule. Addition rule for probability of A and B, or we say A or B. The probability that event A or B will occur is probability of A or B, which equal to probability of A plus probability of B minus probability of A and B. Now, from this addition rule, we can see that it means event A and B are not mutually exclusive. So we have event A plus event B, but minus event A and B. Event A and B is the intersection of A and B, which is the probability that both event A and B will occur at the same time. So again, addition rule, we normally denote it as or. So a probability of A or B is equal to probability of A plus probability of B minus probability of A and B. Why minus probability of A and B? Because the event A and B are not mutually exclusive. Now, for mutually exclusive event A and B, then the rule can be simplified to be the probability of A or B is equal to probability of A plus probability of B. So the addition rule, we have two formulas. If the two events are mutually exclusive, then we use probability of A plus probability of B minus probability of A and B, because event A and B can occur at the same time. This means, again, they are not mutually exclusive. Now, for mutually exclusive event A and B, the answer will be probability of A or B equal to probability of A plus probability of B. Now, we say we can be extended to any number of mutually exclusive events. What we mean, we can have 3 or 4 events, etc. So let's see one example here. Here we are going to use the addition rule. We select a card from a standard deck. Now they say we should find the probability that the card is 4 or essay. Now the total number of cards are 52. Assuming the total number of cards on hand are 52. So what is the probability that we are going to select 4 or essay? Now this will be this will be mutually exclusive. Why? Because in essay card, there's no number 4. Essay is A, there's no 4. Now, for example, if the question says find the probability that the card is Jack and Heart. Now, this will be what? Not mutually exclusive, because Jack can also be Heart. We can have Jack as a diamond or heart, and also we can have a heart. So this again, in this case, to find the probability that the card is 4 or essay, this is mutually exclusive. So the events are mutually exclusive because if the card is 4, it cannot be essay. But now if we say what's the probability of selecting a card that is a jack or a king or dice, in this, or essay or diamond, in this case is going to be not again mutually exclusive. Why? Because again, we have, let's say jack. A jack can be diamond or it can be heart at the same time. So to find this solution, we use the addition rule for mutually exclusive, which will be probability of 4 or essay is equal to probability of 4 plus probability of essay. Now we have, in the total cards is 52. We have 4 for essay also. So it will be 4 over 52 plus 4 over 52, which will give us 8 over 52, and that will give us 0.1454. 0.154. So here we are assuming that the deck of 52 cards, Damo and Art, etc., we have 4 each. Now let's see another example. Here they say we should roll a die and we should find the probability of rolling a number less than 3 or rolling an odd number.